All right, well, welcome back to my channel, everyone. So today I'm going to show you how I designed my swing arm for my first Gen Tundra. Now, I took a bunch of measurements, and then I started laying everything out in SolidWorks. And so this is my swing arm assembly. I have three main components. So the swing arm itself, which is this component, and then I have these two frame mounts. So this is the passenger side frame mount, and the swiveling hinge will be mounted to this side. And then this is the driver's side frame mount, and the free end of the swing arm will be supported by this frame mount. So when the truck is bouncing along a bumpy road, everything on the swing arm will be supported by at both ends. Now, the swing arm itself will have these frame supports or platforms sticking out of it, and I'll use these supports to mount, for example, a storage box. On my truck, I am going to mount my diesel heater in here. So right now I have an H-Calorie Toolbox 2 diesel heater, and to set it up right now I have to take it out of the truck, put it on a table, connect the hoses, connect the electrical, and all that stuff, and it's kind of a hassle. And so I'm going to take all the innards out of this diesel heater, and I'm going to mount it in the storage box. So it'll be permanently mounted in the storage box. And I'm going to design it in such a way that all I have to do to set it up is pull a hose out, connect it to the camper skirt of my truck, and then apply power to the diesel heater, and that's it. It'll be ready to go. So I don't have to set up a table. I don't have to pull the heater out, place it on a table, and connect all the exhaust pipes, intake pipes, and all that other nonsense. So it'll also be protected from the elements because it'll be in the storage container. So right now, if it rains or snows, it just goes on the heater. So it'll be better protected in this storage box. The benefit of having modeling all this out in 3D is that I can also do things like run a stress analysis on this assembly, just to make sure it's going to be able to handle the loads that I'm going to be putting into it. And so what I use is called SolidWorks Simulation. And simulation, the version I have is the nonlinear version. And so it can do linear materials, it can do superelastic materials, it could do hyperelastic materials. So it can do a wide range of material. You can analyze a wide range of materials. So the SolidWorks has two versions, a linear version and a nonlinear version. So the nonlinear version is their top end version of FEA, and that's what I'm using here. But again, once you have everything modeled, then you can start applying loads. So I created this little simulation study. I'm applying a load here. So each of these platforms, I'm applying a 200-pound load. And I'm going to see what that load does to all the various components of the swing arm assembly. So let me create a mesh. Now, I'm also running this in a worst case scenario. So I have this swing arm. Well, actually, it's not a worst case. Let me open it all the way. And let me remesh it. So, this swing arm is in open position. The free end isn't supported anywhere. It's putting max load on all of these components, all this frame support. And let me just back up a little bit. So these frame supports bolt to the frame of the truck using the trailer hitch bolts in these areas. So these three bolts, same as on the other side, uses the trailer hitch bolts. There's also, this piece is also supported with a triangulation bar here, and that also bolts to the frame of the truck. So I'm not showing it here, but you'll see it in the fabricated components. Same with this part, you'll see a triangulation support. Um, let me undo what I just did there. This frame support is significantly beefier than this side. This is a 2x2 by 120 wall. This is a 3x3 by 120 wall. This side has to support all the way to the swing arm. This side only has to support the free end of the swing arm. So this side has to be significantly beefier than this side. This is a 2x4 by 120 wall. And then this is, I don't know, 1.25 by 120 wall part. All right, so created the mesh. I'm adding 200 pounds on each of these ribs. And so now if you look at the stress results, you'll see some colors come up. All right, and so this red arrow shows the yield strength of the material. So I'm using plain steel. Everything is plain steel, the same type of material. So yield strength is right here. Anything above this, and the material is taking a permanent set, so it's bending permanently. Anything below that red arrow, and you're safe. So we are getting into this area where it's green. All right, so I don't know where, but it's getting to that point where it maybe could be permanently bending the material. So I'm going to just do what's called iso clipping, and I'm just going to scoot along. So you'll see as I slide this bar, this black arrow will get closer and closer to the yield strength of material. And so you can see where the stresses are, where the max stresses are coming into the design of the parts. All right, so I'm not too worried about it right now because these holes are going to get smaller. I was going to use a hole saw to make these, and I don't have a hole saw that big. So these holes are going to get smaller, and as such, they'll get stronger. So the way it's designed, this swing arm assembly can easily handle 600 pounds in a static environment, meaning the truck's not moving, right? So the arm is open. I have 600 pounds on it. It's not going to break. All right. So now the truck is going down the road. Now we're talking dynamic loads, right? So now the swing arm is supported by both ends. So the free end of the swing arm will be supported by this side. So I'm never going to put 600 pounds on this. Maybe I'll put max 200 pounds. But even then, we have the swing arm is supported at both ends. Right? So this end, the free end, they're all supported. So even if you're going down a bumpy road and everything's bouncing up and down, this swing arm assembly design should be more than strong enough to handle that. So just trying to be safe. You don't want things falling off on the trail or on the freeway just because you're overloading the material. So it's better to be safer than sorry. Do your homework up front, and that way things don't fall off when you're going down a trail. So I'm going to take the design of this. I'm going to start fabricating the parts, and I'm going to show you what that looks like.
So these are my two frame supports. This is going on the driver's side. It bolts up to using the trailer hitch bolts, triangulates down for additional support. Swingout will sandwich itself in here. So this will get mounted in the truck like this. And then this is the passenger side. This is where the swing out, or the swing arm, swivels on. Same principle. It bolts using the trailer hitch bolts. Triangulates down for additional support. You'll notice this one's much beefier than this one, just because this one has to hold a whole lot more load. And let me show you where they bolt up. So the frame supports will get bolted here and here.